In this video, we're going to discuss strings and their properties and usage, and we're also going to discuss a little bit about object-oriented programming. So, the concept of a programming paradigm is how we program, how we organize our code, how we use our code. Two of the most popular programming paradigms are procedural and object-oriented programming. There's also functional programming, and there's logic-based programming, among others. Procedural programming centers on actions and applies those actions to data. Object-oriented programming centers on data and actions that use that data and attempts to model representations of concepts in the real world. Of the two paradigms, object-oriented programming is by far the dominant one these days. Procedural or structured programming is a much older style, which is much less widely used these days, but some of the concepts still do carry over. C++ enables object-oriented programming by allowing programmers to define their own custom data types, usually referred to as classes. These types are called classes, and their definition describes both the data and behavioral aspects of the class. C++ chose the term class for these data because of similarity with classification systems like taxonomy, birds, falcons, etc., in the biological sciences and classifying animals in the kingdom. Individual items of a class's type, specific type objects within a class, are called instances of that class. So, for example, we might have dog as a class. It might have a subclass called pug, and the pug might have an instance of the class called Charlie. Now, pug would have general containers for things like age, height, weight, whereas Charlie would fill those containers with things like name, which would be Charlie, weight, which would be 20 pounds, and age, which would be 7 years old. Charlie's my dog. So we've seen three classes so far. Cin is an instance of a class representing input streams. Cout is an instance of a class representing output streams. And string is a class representing a collection of characters that are ordered and treated as a single unit. A string can consist of 0 or more characters. You gotta keep in mind, you could have 0 characters, and it's called the empty string. And it's denoted by just 2 double quotes next to each. A string can be treated as an atomic unit, but can also be accessed character by character. A single character and a string within the character, and a string with a single character are different things. Double quote A and single quote A are not the same thing. Some operations we use on strings from the strings library include constructing a string, outputting a string, inputting a space-separated string values, concatenating, joining two strings together, accessing characters directly within the string, comparing two strings lexicographically, essentially alphabetically. There are also utility functions for strings, determining the length of a string, determining if it's empty, inserting a new character into the string, not necessarily at the beginning or end, erasing characters, getting substrings, see if characters exist within a string, replacement, and many more. There's infinite number of them. So the way we declare a string is just say string name equals whatever the string you want. The statement above declares a variable that will contain a string in its name s. Its initial variable is set to empty. This is different than most built-in types, which default in C++ to unknown values. We can also initialize a string with a value. This declares t as a string and initializes its value to the value hello. We can construct constant strings with a value cannot be assigned, just like before, while using the const keyword. You can initialize one string object to be an exact copy of another, and they can be used using a standard constructor by just passing in what they need in parentheses instead of using the equal. It is the same thing. Some use the syntax to show, rather than the equal, to show that initialization is not assignment. Another way to construct a string is by using the character duplicate constructor. Const string border 70 will have 70 stars. Without the parentheses, this would not work because it would be interpreted as trying to initialize a name to variables. We want to take a look at an example. To have the complete access for all string functions available to you, you include string. Okay. So let's say string first equals Larry. That's the example we gave before. Oops, I forgot my namespace here. String. And then now what we can do is we can create a duplicate string second equals first. We print out second. Let's put some verbiage in here so we can actually see what we're printing. Second. And if we run it, we'll get exactly what we think, which is, all right, it prints it, and it's a duplicate. So now what if we assign first a different value? So now if we run these two statements again, will both be changed, or will just one be changed? Just first be changed? What do you think? The reality is that only the first one will be changed because they're separate copies. Okay. We can use some constructors with character functions, string constructor. Let's say it's 70 characters, and we'll give it an underline, and then we will print that string. And there we go. Sorry, the screen isn't quite wide enough, but this just duplicates the character 70 times. So now we're going to return back to our PowerPoint. Whoops. You can output strings using cout with the insertion operator, just like everything else. On an output stream like cout, later we'll learn to use other output streams. But T/S, and then we include an exclamation point and the new line character. We can display the border question between tabs, so this first one would be a tab, and then the string border, and then a new line. During program execution, you can change one string to look like another with the assignment operator, just like you've done for built-in types. Same thing as we've always done. Extraction as the operator to read into a string, but extraction will not store spaces, even into a string. It will separate the user's input into words at space boundaries and bring them in one at a time into your strings. So let's give an example. Let's put in a thing here. We'll say string input, and we will say say input. Sorry, can't type today. And then we're going to just print out input to see what we get. All right. So we'll run it with one word, and it works like we think. But let's put a sentence in there. This is a test. And it breaks it up into words. The only way we could get multiple words using cin would be or one of the only ways. Oops. Okay, so now sorry, I can't type today. And we still lose the test. So, this would only contain this. Now, coming back here for a second, we will find out, I'll show you a way around it. The way we're going to get around it is by using the Getline function. Pop over and show you that. Oops. Oh, my computer is being a pain in the butt. All right, so we don't reuse what we did before. We're going to comment this out because I don't want to waste time re-entering it, and that way you guys can play with it. So let's put in a couple comments just so we know what they were initially. So this was basic string usage, creation, initialization, assignment. And then we will say here that using cin strings, and then for here, for this section, we will do using Getline. So we'll declare our input variable as before. Now, if you have the other stuff in common, that'll go first. So. Oops, I can't write the right input line. And then what we'll say is the statement Getline, which takes as a parameter the input string you want to use, and then the string you want to assign it to. Now, for some reason, I can't type this in my life today, but I think you get the idea. Alrighty, and let's put in a prompt because it makes more sense. Now, if we run it, let's put in a real sentence. Test of a sentence. Boom! We don't lose a single word. So when you're using strings, if you're going to have spaces in them, be careful and go ahead and use Getline instead of cin, using the cin extraction operator. So, concatenation is a way to attach one string to another. We use the plus operator, which is called concatenation. So, we have string T and string S. If we say T plus S and output it, it will give us hello Bob. Notice I have a space in the first string. Now, we could do this as a statement, T plus S semicolon, but it won't do anything. To store the result rather than print it, you assign it to another variable. And it can still be printed just like a normal variable. So let's take this example. And here we'll do what we did before. And we'll comment this out. And we'll say, hopefully you guys will type better than I am today. And here we'll say that this will be our concatenation example. So we're going to say inputs. Okay, and then we'll say, we'll call this just first. And then we can say string class name. Notice I can't call it class because that's a reserved word. Equals first plus second. So now we can print out everything. First equals first. Oops, I'm going to print a new line here. And then we'll go on print second the same way. Second. Result equals now notice here that I finish things up with an endl instead of another third new line. And the reason I do that is because that way we will clear the buffer too, besides just throwing a new line. So if we run this, we get the strings put together. You can do more than one. Okay. We could say this. We could say string course title equals class name plus space in there, intro to. Now something else we could do if we wanted to is we could actually isolate the space and put it in as a third string. You can add as many as you want. Okay, so now given this, copy before, and then we will add this guy now. Course title. And the other thing I want to do is I want to put in a couple new lines to separate it from the previous stuff. And that'll put 3 new lines. So here's what we get. Here's the first stuff, and here's the second stuff where we've concatenated all this. Oh, it looks funny because I forgot to include my endl after, my new line after my second class name. So we run it again. There we go. Now it looks right and makes sense. Concatenation is very free form. You can concatenate strings with characters and characters with strings, but you cannot concatenate just chars or string literals. You'll need a helper string. So you can't assign a character to a string, but you can use the string constructor with an argument of 1 to do that. And we will take a look at some of these. So, given that, we're going to also look at some oddities with C++ and concatenation. So, let's say we have string S1 equals ABC. We can say string S2 equals S1 plus CDEF, and that works fine. But if we say this, that's not going to work fine. It'll give us a syntax error. Basically, C++ is requiring that one of the parts of a concat, any one of them, be what's called an L value, or a left side of an equation. S2, and now boom, that goes away. But we can do things like this. And we still have a problem. You just can't have strings, raw strings, side by side. Now, you might ask yourself, why can we do this then? And that works fine because the less than operator doesn't concatenate these two. Or the double less than, the insertion operator. But this will give us the same problem. Basically, addition on strings requires at least one actual variable on the right-hand side. Now, that is a little strange because other languages don't make you do that. The same also applies for char can add chars to strings, and as long as you store them in a string, no problem. And we have a problem with it. So, concatenation works, but it's just slightly picky. Let's just count this guy out. Go back here. And here we talk about C-line again, but we've already done it. I mean, Getline, I'm sorry. And that covers strings.